This short animated video explains the basic concept of p-value in statistics with help of some relevant examples. So don't go anywhere else, just sit back, relax and enjoy this video. So what is p-value? Let us understand the p-value from statistical perspective. So p-value is the probability, a number between 0 and 1, calculated under the assumption that the null hypothesis is true. P-value is an evidence against a null hypothesis. In statistics, p-value is also known as the probability value. It is the smallest level of significance at which the null hypothesis is rejected. P-value are generally expressed as decimals, although it may be easier if you convert them into percentage. Smaller the p-value, stronger the evidence that you should reject the null hypothesis. Usually the p-value of 0.05 is used. So if you convert this into percentage, it comes to 5%, which means that there is a 5% chance that your result could be random. That is, it would have happened by chance. On the other hand, the larger p-value, say for example 0.9, means that your result have 90% probability of being completely random and not due to anything in your experiment. Therefore, smaller p-value, more the significance your result would be. Let's say an experiment is performed to determine if the coin flip is fair or not. So you flip the coin. You have equal probability of getting a head or tail, that is 50 or 50 or 0.5. Now suppose if you flip the coin for 1000 times, it follows a normal distribution curve, and on an average we would expect to have 500 tails and 500 heads. But if I got 510 head and 490 tail, then would you call this a fair coin or an unfair coin? But in this case, we can say there is no sufficient evidence to suggest that the coin is fair or not. Right? So if again, if we get another case where we have 800 heads and 200 tail, would you still call this coin a fair coin? I guess we cannot call this a fair coin because we would have a strong suspect that this is an unfair coin and is biased towards the head. So in this case, we would suspect the coin is biased, and this could be easily happen by chance. Graphically, if you represent the p-value, it is the area in the tail. That is the red area that I have marked. That is the distribution of your graphical distribution. My null hypothesis in this coin would be that my coin is fair and it should have equal probability. It is a default of worst case scenario. It is a known fact that it will have 50% head and 50% tail. And my alternate would be that is not 0.5. That is how you define the alternate and null hypothesis in this case. The chance of occurrence of null and alternate are mutually exclusive. This means then either of them can occur. Both cannot occur at same time. That is basic about the p-value. Now let us look at some decision rules. How do we, based on that, we will evaluate whether our result is significant or not. Decision rules. To understand the decision rules, let us first plot the normal distribution curve. And these are my critical values. Now my first rule says if p less than alpha, that is the significance level, then we can reject the null hypothesis if it falls in this red region, which is below the critical values. The term significance here means not anything major or important, but it just means the difference between two mean is not likely due to chance. And as the p gets further lower, the evidence allow you to reject the null hypothesis gets more stronger here. The second rule is if p is greater than alpha, that means we fail to reject the null hypothesis, which falls in this green region here. The p-value lies between 0 and 1. It won't reach exact 1 because in real life the group will probably not be exactly perfectly equal, and it will also not reach 0 because there's always a possibility even if it is extreme. So alpha here denotes the level of significance, and how you calculate? You calculate from 1 minus confidence level here. So before we start some numericals, let us do a quick check to understand how much you understood this concept till now. First question. The result is statistically significant whenever the null hypothesis is true, the alternate hypothesis is true, the p-value is less than or equal to significant level, and the p-value is larger than the significance level. Second question. The p-value is also known as problem value, probability value, proportion value, and the personal value. Question 3. P-value is the probability of rejecting your null hypothesis. Is it a true statement or a false statement? You can leave your answers in the comment section below. Let's take the first example of single population mean. A vendor claims that the average weight of box is 1.84 kg. The customer randomly chooses 64 parts and finds the sample weight as 1.88 kg. Suppose the population standard deviation is 0.3 kg with alpha at 0.05, that is the level of significance. We need to test for hypothesis that the true mean of shipment is 1.84 kg. So my null hypothesis is that mu is equal to 1.84 kg, and alternate is it is not equal to 1.84 kg. Alpha or level of significance as 0.05. So let's plot it on that normal distribution curve. We mark it the area, rejection area. Here, if it falls in the red region, we will reject our null hypothesis. If it falls in between, we fail to reject the null hypothesis. So we'll use the Z formula, that is x power minus mu by sigma by under root n. We'll put all this value here. We get Z calculated as 1.07. When we go back to Z table here, we find out what is 1.07. So 1 from the Z table on the last column and 07 from the vertical column. So we get 0.857. So this entry in this table is the standard normal curve to the left of the Z value. That means I'm getting P as 1 minus 0.8577. Since the normal distribution is symmetrical, so area to the right of the curve is equal to that of left. That is why we have calculated 1 minus 0.85, and we get P as 0.1423. So in this case, my P is greater than alpha, that is 1.4323 is greater than 0.05. So since P is more than significance level, so decision will be to fail to reject my null hypothesis here. So this is how we do it based on P value. Let's take another example for single population proportion. 6.9% of the people are below the poverty line. Researchers find out that this percentage is higher for their own village. He conducts a survey on 300 people in his village and find out that 30 out of 300 are below the poverty line. Assuming the alpha of 0.05, we have to find out whether his claim is justified or not. So my null hypothesis is P naught equal to 0.069, which is coming from 6.9% of the population. Alternate hypothesis is P naught is greater than 0.069, since his claim is that his percentage is higher in his village. So we'll use this formula for calculating Z calculated, that is P hat minus P naught divided by under root of P naught into 1 minus P naught divided by N, where P naught is equal to 0.069, P hat is X divided by N. So X is 30, the result that he got out of 300 samples in his village, and P hat is coming as 0.1. Now we'll put these values of P hat and P naught in the Z calculated formula. We get Z calculated as 2.12. We go back to Z table, but first let us plot this in the normal distribution curve. In the Z table, we'll find out 2.12, which comes at the intersection of 2.1 and 0.002. We get 0.9830. So this 0.9830, since area under the curve is 1, we subtract it from 1. So we get P as 0.017. Since this 0.007 is less than 0.05, that is significance level alpha. So we reject the null hypothesis in this case. This is another example of p-value. So I hope with this you now have very good understanding about p-value. So if you like this video, do give a thumbs up, share this video with all your friends, and don't forget to subscribe and hit the bell icon as well.